everybody, welcome to our first episode of Isabel Explains, and today we're going to be talking about domain versus range. I believe that this is a topic that a lot of students struggle with, especially when we get to more complicated functions, but I think it is a very important foundation to understanding functions, especially down the line where you're going to be talking about other topics with functions. So let's start with the linear equations, okay? The linear equations or linear functions usually are written as y equals mx plus b, right? Where we have m is the slope, b is the y-intercept. In this case, I'm just going to keep it super simple, and I'm just going to use, actually, I'm going to be using the simplest version of every of the equations or the functions. So if we have y equals to x, well, the first thing that we have to do, we know that the domain is all of the possible values of x, and the range is all of the possible values of y. So, but the values of y are dependent on the values of x. So we always are going to evaluate x first. And we're going to find out what restrictions do we have to that possible value of x. If we can find out the restrictions, or what x cannot be, then we can find out what it can be, right? So in this case, x can be literally any value. There's no value that I can make x that is going to make this equation impossible, and we're going to see that a little bit later. So the domain, then, we're going to call it, it's going to be from negative infinity from positive infinity, meaning that it's going to include all of the possible negative numbers, 0, and all of the positive numbers as well. So now let's look at the range. We know that x can be literally anything. So if y equals to x, well, that means that y can be literally anything, right? So the range is also going to be from negative infinity to positive infinity. All right, now moving on to the quadratic equation or the quadratic function. So if y equals x squared, are there any values of x that the x cannot be? Can it be a negative number? Yes, it can be a negative number. Can you square a negative number? Yes. Can it be 0? Can you square 0? Yes. Can it be a positive number? Absolutely. Which means that the domain of this function then is going to be from negative infinity to positive infinity as well, because there are no restrictions for x. However, let's look at the y. Y is the squared, right, of x. So that means that every time x is a number, y is going to be the square of that. So can y ever be a negative number, for example? Well, the answer is no, because there are no number that I can square in terms of x. There's no number I can square that is going to give me a negative number. For example, even if I have something like negative 2 squared, well, that's actually 4. It's not negative 4. So therefore, my y is never going to be a negative number. That means that y cannot start at negative infinity, right? But can it be 0? Yeah, it can be 0, because 0 squared is 0. So my range actually starts at 0. So it's going to be from 0 to positive infinity, because can it be a positive number? Absolutely. It can only be a positive number, actually, besides 0. So it's going to go from 0 to positive infinity. All right, what about the radical equation or the radical functions? Well, in this case, x, actually, we're going to start seeing a restriction for x, because x is going to be trapped inside of a square root. And we know that there are no numbers, no negative numbers that you can find the square root for, because there's no number that you can multiply by each other, just like we saw in the previous example. There's no number that you can multiply by each other that is going to give you a negative number. So therefore, x cannot be a negative number. That means that x either has to start at 0, or the domain is going to have to start positive infinity, or go to positive infinity. So can it be 0? Yeah, it can be 0, because we can do the square root of 0, which is 0. So the domain actually starts at 0 to positive infinity, because we know that the domain cannot be a negative number. And actually, I just caught myself. I realized I made a little boo-boo here. that 0 has to be included on the previous one as well. So we draw this little bracket instead of the parentheses. The parentheses means it's not included. The bracket means it is included. The 0 has to be included here. Why do we draw parentheses on infinity? Well, because infinity is not really a number, so we can't really include infinity. All right, so it's just more of a representation of like forever. All right, so what about the range then? The range of the radical function, it's gonna have to be, again, dependent on the values of x. So what possible values can the y be? Well, can the y be a negative number? No, because if you find the square root of any number, it's never gonna be negative. And even if we make it a negative number here, and I encourage you to try it on your calculator, if you do the square root of a negative number, it's either going to say error or it's going to give you an I at the end of it. It's going to be something plus I, and that means that it's an imaginary number, which we're not going to talk about today. So the range of this function, then, it's going to have to start at 0, and it's going to continue all the way to positive infinity. So the range actually happens to be the same as the domain. So let's talk about rational functions. So in this case, can x be any number? Let's think about that for a second. Can x be negative? Yeah, it can be negative. Can we have negative equations or negative fractions? Yes, we can. But can it be 0? No, it cannot be 0. And you can try that on your calculator again, where if you do 1 over 0 or any number over 0, the calculator is kind of going to yell at you and it's going to say this is undefined or error, can't divide by 0, whatever. And that means that the x cannot be 0. But can it be a positive number? Yeah, it can be a positive number, right? So wait a second. Now I'm seeing a gap in my domain. So meaning that I can start at negative infinity, right? And I'm going to get really close to 0, but I'm not going to touch it. Okay? But how do I write the rest of it? I still have from 0 to positive infinity without including the 0. Well, what we do is this little sign called union. All right? And that is going to link those two domains, so to speak, or it's going to unite the entire domain. So what about the range of this? Well, we know that x can never be 0, and x can be negative and x can be positive. So what does that mean to the y? Well, so is the y ever going to be negative? Yeah, it's going to be negative. So we start definitely at negative infinity. But is the y ever going to be 0? No. The y is never going to be 0 because x, for one thing, cannot be 0, which would be like our only shot at it. But also because there's no number that I can make x that is going to make my y 0. So I'm going to have this same range as the domain. So my y is going to start at negative infinity, it's going to continue to 0, and then it's going to have the same union from 0 to positive infinity because it can be positive numbers as well. All right, so let's move on to the last one. We're doing exponential functions. And in this case, I would have used 1 to the x power, but that would have just given me 1 the entire time because it doesn't matter what you elevate 1 to, it's always going to be 1. So I chose 2 instead. So 2 to the x power, y equals 2 to the x power. Well, what is going to be my domain? What restrictions do I have for x? Well, none. Because x can be a negative number, x can be 0, and x can be a positive number, so it doesn't matter. So my domain is actually going to go from negative infinity all the way to positive infinity. However, let's look at the range. All right? So there are 2 things that the y is never going to be. The y is never going to be negative, and the y is never going to be 0. And I'm going to show you why. So let's suppose I make my x a negative number, right? So let's suppose I use 2 to the negative 1, right? So that is not going to turn my 2 into a negative number. It's actually going to turn it into a fraction. So this is going to become 1 over 2 to the first power, which is just 1/2. All right, so if I turn it 1 to the negative 3, this is going to be 1 over 2 to the third power, which is 1/8. Okay, and so on and so forth. So therefore, my y is never going to be a negative number, no matter what I make the x. So my y is also never going to be 0, because I can make this exponent like really negative, so to speak, right? I can make it negative 2 to the negative 100th, right? And what that's going to do is just going to make 1 over 2 to the 100th power, okay? And that is still not 0. It's going to be really close to 0, but it's not going to be 0. So the range is not going to be negative. It's not going to be 0. So therefore, it is going to start as 0 without including the 0, and it's going to continue all the way to positive infinity. All right, let's see that in action. So here is the representation of all of these functions, all 5 of them. So let's start with the linear one. We know that the first one, it's gonna be from negative infinity to positive infinity on the domain, which means that if we're gonna scan the function from left to right, we're gonna start at negative infinity here, right? It keeps going to the left, and it continues to the right. So all the way to the right. So it's gonna be to positive infinity. Now, if we scan it from bottom to top, we always, when we're assessing the domain and the range, we always go from left to right and from bottom to top. It's what I like to call good math grammar. Okay, so this graph actually is going to continue going down, right? It's always going to continue going down. Therefore, it's going to continue to negative infinity, or it's going to start at negative infinity, and it's going to continue going up. Therefore, it's going to continue all the way to positive infinity. If we look at the quadratic function, this one is going to be, we know that the domain is going to go from negative infinity to positive infinity. So it's going to keep continuing, and you may not see it right now. It looks like it's going straight up, but it's not. It's actually expanding ever so slowly, but it keeps expanding from left to right. Therefore, the domain goes from negative infinity to positive infinity, and the range is going to start at 0. It's going to start right here at the origin in this case, and there's nothing below it. No part of the graph is going to be below it. So the rest of the graph is actually going to keep going up all the way to positive infinity, starting at 0, including the 0. If we look at the radical function, we are going to see how it starts at 0 on the domain, right here in the origin as well, and it's going to continue all the way to positive infinity this way. Oops, that's the wrong marker. It's going to continue to positive infinity this way. And if we look at the range, it's also going to keep going up and up and up and up and up and up and up. Now, it doesn't look as obvious, kind of the same with the domain of the quadratic function, but it is going up. It's because the greater you make the x, the greater is going to be the y, even if it's not as obviously large. So it's going to keep continuing all the way to positive infinity, and it started at 0 as well. And then if we look at the rational function, we're going to see it right here, and this is where we see the gap. You see how we have the union here is because there is a big gap in that graph, and it starts at negative infinity on the domain. So if you see, it starts all the way here. It's going to keep continuing. I just didn't draw it because my marker is too thick, so it would have overlapped on the x-axis. But it continues all the way to negative infinity, and on this side, it continues all the way to positive infinity as well. And on the range, we can see that it continues all the way down, which means that it actually starts at the negative infinity section of the graph, and it continues all the way to positive infinity. Now we see that gap in the middle, and we know that what is never going to be is 0. You see how it never touches the 0 in any location, and that is because it is actually approaching 0 both on x and y, but it's never going to touch it. Now, last but not least, we have the exponential graph, And this exponential graph, we know that the domain is from negative infinity to positive infinity, meaning that it, again, same thing with the marker being too thick. So it keeps going all the way to negative infinity, and it's going to continue that direction. Therefore, it's going to continue all the way to positive infinity. There are no gaps in between, so we don't need any unions. But for the range, it actually starts at 0 right here without including the 0. So that means that my x-axis is actually asymptote, and we're not going to talk about that, but it's very important that you know them eventually. And my y is going to approach 0 very, very, very close, but it's never going to touch it. And you can try this on your calculator. Try to zoom in, and you're going to see how the line keeps getting close and close and close and close and close, but there's always going to be that small gap, and it's never going to touch the x-axis. But if you keep going up, it's actually going to keep going all the way to infinity and beyond on the positive axis. So that is it for today, guys. Thank you so much for watching. I hope you enjoyed it. I hope you learned something, most importantly, and I will see you guys next time.